Welcome to solverfy.
So for question 15, part A, we have to find the mass of 4.16 times 10 to the 21 mole of nitrogen dioxide in kilogram. Okay, so again, when we want to find the mass, we need to know the number of moles, but we are only given the number of molecule. So we have to convert that to the number of moles. So the number of moles for NO2 essentially equals to our number of molecule divided by the Avogadro number 6.02 times 10 to the power 23. So from here we are 4.6 times 10. 4.6 is not 4.61. It's 4.6 times 10 to the power of 21 divided by 6.02 times to the power of 23. So we will have 7.6 times 10 to the 3 moles. Okay, so what would be the molar mass of NO2? We want to find the mass. So mass will be equals to our number of moles times our molar mass. So the molar mass of NO2 will be 14.01 plus 16 times 2. So we have 46.01 gram per mole. All right, so we just need to multiply our number of moles and the molar mass together, and then we will have our mass in gram. So it will be equals to 0.35 gram. Okay, but we want it in kilogram. So we know that for 1,000 gram equals to 1 kilogram. So when convert gram to kilogram, we just need to divide by 1,000. So we have 0.00035 kilogram. Okay, so part B, what would be the amount of number of moles of chlorine atom in 0.615 C2H4Cl2? So if we want to find the number of moles, we just need to use our mass, 0.0615 gram, divided by the molar mass. Okay, so the molar mass, we have to calculate that. So we have 2 carbon, we have 4 hydrogens, and then we have 2 chlorines. So it's roughly around 98 gram per mole. So what would be the molar mass? What would be the number of moles? So we just need to input in a calculator. So we have 6.28 times 10 to the negative 4 moles of this molecule. But we are interested in the number of moles of chlorine atom. For each of this molecule, we have 2 chlorine atoms. So we just multiply that by 2. So we will know that it's roughly around 6.28 times 10 to the negative 4 times 2. So it's 1.26 times 10 to the power of 3 moles of chlorine atom. Okay, so for C part, what would be the number of hydride ion in 5.86 gram of thorium hydride? So again, let's find out the number of moles of thorium hydride. So it will be 5.62 gram divided by the molar mass of thorium SiH2. So Si is 87.2 plus we have 2 hydrogens, so that's just 2. So 89.2 gram per mole. And then we have 5.62 divided by the answers. And then we should have 0.0649 moles of the SiH2. Okay, so how about the number of moles of hydride ion? For each of the molecule, we have 2 hydride ion. So we just multiply the number of moles by 2, and then we should be able to find it as 0.1 0.0649 times 2, 0.1298. But we are going to wind up to 0.130 moles. Okay, so there's a number of moles of hydride. We just need to convert that back to the number of ions. So we just multiply that by our Avogadro number. And then we will have a number of hydrogen 6.02 times 10 to the power 23, and then we should have 67.83 times 10 to the power of 22. and this would be the number of ions.